5 years ago, Starship blew up on the pad. 3 years ago, it started reaching space. Last year, it caught a booster mid-air with giant robot arms in what might be the single most absurd engineering achievement since the moon landing. Now they're flying V3, working toward orbital trajectories and closing in on the refueling demonstration that unlocks everything else. The moon is coming, Mars is coming, the 40-minute London to Sydney flight is coming eventually. Whether Flight 13 sticks the landing or adds to SpaceX's growing collection of dramatic splashdowns, the trajectory of this program is pointed somewhere humanity has never been before, which is exactly what space is for. Before I talk about how Flight 13 changes everything, let's be honest about what just happened. On May 22nd, 2026, SpaceX launched Starship version 3 for the first time. The new V3 design, bigger, supposedly better, definitely more dramatic. The upper stage, Ship 39, actually did great. It flew to suborbital space, deployed dummy Starlink satellites, and made a successful splashdown in the Indian Ocean. Cool, fine, lovely. The booster, the 33 engine, 230-foot Super Heavy, it had other plans after stage separation. Multiple Raptor 3 engines, debuting for the first time on this flight, failed to ignite during the boost back burn. The booster attempted a recovery, limped through a partial landing burn, and then unceremoniously face planted into the Gulf of Mexico at high speed. Uncontrolled splashdown. The FAA was so thrilled, they put 5 aircraft into holding patterns and delayed 6 departures. SpaceX's reaction, as always, was essentially nominal test data acquired. The FAA's reaction was investigation now. So here we are. Flight 13 is currently scheduled for around late June, though after what happened, analysts at NASA Spaceflight suggest a July to August 2026 window is more realistic. The FAA mishap assessment is expected to wrap by June, and a launch license for Flight 13 is anticipated for Q3 2026. The Raptor 3 engines are under the microscope, and SpaceX is almost certainly not going to attempt an orbital trajectory on Flight 13, nor a chopstick catch of either stage. It'll likely be a repeat of Flight 12's profile, but hopefully with a booster that remembers how gravity works. All of that sounds underwhelming until you realize what Flight 13 is actually building toward. Orbital refueling. The thing that changes everything. Let's talk about fuel. Specifically, the fact that Starship needs to refuel in space, and doing so will unlock literally every other ambition on this list. Here's the problem. Starship is enormous, but space is more enormous. Getting to Mars requires roughly 1,200 metric tons of propellant. That's not a typo. That's 1,200 tons. You cannot carry that from Earth in one shot, not even close. So SpaceX's plan is to send up dedicated tanker starships, basically flying fuel trucks that dock in Earth orbit and transfer propellant to a mission-ready Starship before it heads to the moon or Mars. Think of it as a gas station in space, except the gas is super-cooled liquid methane and liquid oxygen. The pumps don't work in zero gravity, and if you get it wrong, you have a very expensive fireball. SpaceX transferred about 5 metric tons of propellant between internal tanks of the same Starship back in 2024. In 2026, they're planning a full-scale transfer between 2 separate Starships. That's the milestone. That's the one that opens the door. To put it in scale, each tanker carries around 100 tons. A Mars-bound Starship needs 1,200. That means 12 tanker flights just to fill one ship. And for a fleet of 5 Starships, you're looking at 60 tanker launches. SpaceX is literally planning to build a logistics operation in low Earth orbit. NASA is paying close attention because their entire Artemis 3 moon landing plan requires Starship to pull this off. Around 10 tanker launches are needed just to fuel the human landing system before it can touch the moon's surface. And right now, nobody, not SpaceX, not Blue Origin, not anyone has done this between 2 large spacecraft in orbit. If Flight 13 and its successors can validate this architecture, everything downstream becomes possible. If it slips, everything downstream moves with it. Moon missions, back to basics, but make it permanent. Here's something that doesn't get said enough. We haven't had a human being on the moon since 1972. That's over 50 years. Apollo 17 landed, the astronauts played moon golf or whatever, came back, and humanity collectively said, neat anyway, now we want to go back. And this time, we're not planting flags and leaving, we're building infrastructure. NASA's Artemis program has Starship as its human landing system for the lunar surface. Artemis 2, a crewed flyby mission without a landing, is set for 2026. Then Artemis 3 will be the actual lunar landing, currently targeting late 2027 to 2028, with both SpaceX's Starship and Blue Origin's Blue Moon lander as candidate systems. But here's the political drama nobody's discussing loudly enough. If SpaceX keeps having FAA mandated delay after delay, NASA might just pivot to Blue Origin's Blue Moon Mark II lander for the 2028 mission instead. That would be a bad look for Elon, and a very good quarter for Jeff Bezos. SpaceX's 2026 roadmap isn't just about test flights, it's about proving 3 things in sequence: long duration performance in space, propellant transfer in orbit, then a full lunar landing sequence demonstration. Once those boxes are checked, the moon becomes a destination, not an achievement. A waypoint, not a finish line. Mars cities, not as crazy as it sounds. Well, maybe. Elon Musk says SpaceX could launch 5 uncrewed starships to Mars in 2026. He also says the odds are roughly 50-50, which is either visionary confidence or the most expensive coin flip in human history. More realistically, the 2026 Earth-Mars launch window will probably pass without a mission. The technical prerequisites, orbital propellant transfer, long-duration life support, precision landing at scale, are still being developed. The moon, as Musk himself has acknowledged, is the proving ground. But the end game is clear, and it hasn't changed. A self-sustaining city on Mars, thousands of people, local resource extraction. A civilization that doesn't go extinct if something goes badly wrong on Earth. Now, before you roll your eyes, that's fine, roll them. Consider the math. Starship, when fully operational, is designed to carry up to 100 people per flight. At scale, SpaceX envisions launching a fleet during every Mars window, which opens once every 26 months. Over decades, with propellant produced on Mars using local CO2 and water, ships could be fueled for return trips using resources already there. It sounds like a Christopher Nolan movie. It's also technically an engineering plan that actual humans are executing right now in Boca Chica, Texas. The catch? Every single part of this plan depends on orbital refueling working. If that fails or keeps getting delayed, the Mars city is just a very expensive PowerPoint presentation, replacing aircraft London to Sydney in 40 minutes. This one is genuinely wild and somehow gets the least attention. SpaceX has a deal with the US Air Force Research Lab and Space Force worth around $200 to $300 million for a program called Rocket Cargo, or point-to-point delivery. The concept used Starship to fly military cargo anywhere on Earth in under an hour. For reference, a C-17 military transport aircraft takes about 18 hours to fly to any location on Earth. Starship would do it in 30 to 40 minutes at Mach 20 through space. SpaceX is planning to begin testing landings at Johnston Island in the Pacific as early as 2026. The commercial implications are staggering. Commercial passenger flights between continents in under an hour could be a reality by the mid-2030s. Yes, you'd be riding a rocket. Yes, there will be G-forces. Yes, some percentage of passengers will immediately regret their life choices. But for the kind of person who currently flies business class on 14-hour overnight flights and calls it acceptable, this might be worth it. The Air Force, for their part, is primarily interested in delivering supplies to forward deployed troops, bypassing contested airspace and congested sea lanes entirely. The geopolitical implications of that are significant.